Guys, welcome back to Eli UW. Today we're going to be working on reducing matrices. And I say reducing matrices because I don't want to confuse you guys with, reduced row echelon form and row echelon form. So I'll give you a few reminders. So this is what an augmented matrix looks like. We have an array of a bunch of numbers, and then there's this line, and that represents the equal sign. And then we have this, we call it the B vector, which contains basically the right-hand side of all our equations, right? So a matrix is a way to collect a bunch of linear equations. And then when we solve the matrix, right, we want a leading 1 in each of these diagonals. And then we can just read off the solution x1 equals blank, x2 equals blank, or x equals blank, y equals blank, z equals blank, whatever. And when we say a matrix is m by n, that means m rows and n columns. Okay. So what I'm basically going to do is I'm going to do two examples. The first example is going to not be an augmented matrix. I'm just going to show you show you all the operations that we can do to reduce a matrix. And then the second matrix will be an augmented matrix, and then I'll show you how, when we manipulate the left-hand side, we can read off the solution, right? So let's just go over the operations that we can perform to reduce a matrix. We can add or subtract rows. Keyword here is rows. We don't work with columns. We can swap rows. And we can multiply a row by a constant. And notice that, these are the same things that you could do to some linear equations. You could add or subtract two linear equations when you do the not the elimination method, or the substitution method or whatever. You can do that. You can swap equations easily. You can relabel equations. Doesn't matter. And you can, if you multiply an equation by a constant, it stays the same. It's equivalent, right? It doesn't say the same. It's equivalent. Let's box that. And before we begin, just a quick note: there's no unique way to do this. So we could be reducing the same matrix, and I could do it one way, you can do it the other way. As long as we end up with the same answer, they're both correct. So let's look at the matrix that we want to consider. So I picked this one: 1, 2, 6, 4, 2, 8, 2, 6, 4. And we're just going to label our columns, C1, C2, C3, and our rows, R1, R2, R3. The columns I kind of just labeled for fun. We're going to work with the rows. So I'm going to write down my steps and how I'm going to reduce this to the identity matrix. And I'll write down some strategies along the way. One is that we're going to want only one row to change at a time. One row changes at a time. So for me, you'll see me. So I'll show you. The first operation I'm going to do is R2 minus 2R3. So for me, to keep it straight in my head, I write R2 down first. That means I'm going to change R2, and I'm going to leave R3 alone. And so to make sure that I do that, I write down the R3 row before I write down what I've changed. Because that's where, this doesn't get tricky. Because you can see all you can do are three things. You can add or subtract rows, you can swap them, you can multiply by a constant, and there's no unique way to do it, so you can do it whatever way you want. So when it gets hard is you make silly mistakes, and so you want to find a way to minimize those as much as possible. So as I said, this is our first operation. I'm going to take the row R2 and I'm going to subtract it by R3 after multiplying it by 2. First thing I do, I write down row 1 because I'm not changing that. I write down R3 because I'm not changing that. Now, R2, we can see why I did this, right? So R3 has a 2 in this, left-hand corner, and this is a 4 right here. I want that to be 0. So one of the strategies is you want zeros under the leading one. Like, that's the first thing you should do, is go to the first leading one, find 0, and make sure that the two numbers below it are 0 or 3 or however big your matrix is, right? So multiplying this row by 2, I'm going to make this a 4, and when I subtract it, this will become a 0, right? And then, you guys can kind of check the math. This will be a minus 10, and this will be a 0. Second operation I'm going to do R2 times negative 1 over 10. And that's just because there are two zeros here, and there's a negative 10 here. So if I divide by negative 10, this is going to be a 1. So this R2 is going to be done. That row is going to be done. So write that down quickly. We're going to not change R1 and R3. And R2 will be 0, 1, 0 now. Okay. My third step is I'm going to do R3 minus 2R1. Why am I doing that? Because here's a 2 and here's a 1. So I know if I multiply R1 by 2 and subtract this, then I'm going to get a 0 here. Let's write down what I get. I'm leaving R1 alone, so I'm going to write that down. 2, 6, leaving R2 alone. And this is going to become 0, 2, negative 8. And now again, I'm gonna multiply by a constant. That constant being 1/2, so that I get a 1 here, and then I can start eliminating stuff from R1. So R3 times 1/2. Again, R1 doesn't change, R2 doesn't change, and R3 becomes 0, 1, negative 4. Okay, now we're getting somewhere. Now I'm going to do two steps at once. Hopefully that doesn't scare you guys. I'm going to do R3 minus R2, right? And that's just to get rid of this 2 right here. Sorry, R3. I'm subtracting that by R2 here, so I'm going to get rid of this 1. And then I'm going to also divide R3 by negative 1/4 to get a 1 here. Right? So I'm going to get 1, 2, 6, 0, 1, 0, 0, 0, 1. And now we have the exact form we want. The last step is to get rid of this 2 and this 6. So we just have to multiply R2 by negative 2 and R3 by negative 6. Add them to row 1. So R1 minus 2R2. R1 minus 6R3, and we will get the beautiful identity matrix. And that's done. So now let's do a little exercise with the augmented matrix. So our new example will be this matrix B, 4, 2, 1, 3, and then after the equal sign, we'll have 6, 7. And you'll notice I didn't use the swap row technique. We'll use it in this one. So let's write out what these equations are, right? So this is just 4x1 plus 2x2 equals 6, and x1 plus 3x2 equals 7. Right? We've collected them now in this matrix. We want to solve this equation. We want to know what x1 and x2 are. To do that, we want to make this left side of the bar to be identity matrix. We want a 1, 0, 0, 1, and then we could just read off x1 equals blank, x2 equals blank. So we'll see how we get that. First step, I'm gonna swap R1 and R2, and I'll just label this R1, R2. R1 swap R2. And why is that? Because there's a 1 here. So if I swap these, I get a leading 1 for free. I don't have to do anything other than swap. So this is 1, 3, 7, 4, 2, 6. Right? Second one, I'm going to do R2 minus 4R1. Right? We want to get rid of this 4 here. So I'm going to multiply R1 by 4 and subtract off that. I'm going to get 1, 3, 7. R1 doesn't change. And R2 become 0, negative 10, negative 22. All right. Third operation, I'm going to do R2 times negative 1 over 10. Just like before, I want a 1 here, right? The easiest way to do that is to divide by negative 1 over 10. So 1, 3, 7. R1 doesn't change. 0, 1, 22 over 10. This is, again, where this question gets confusing for students is, you get messy fractions like this. But, just if you have to, use your calculator if you're allowed to. But that's something you should practice, obviously. And so our last step is going to be R1 minus 3R2. And we'll get, again, we're going to multiply this by 3. And that's going to make this a 0. So we're going to get 1, 0, 0, 1. Exactly what we want. And that is going to equal 2 over 5 and 22 over 10. Row 2 didn't change. Right? So now we can just read off the solution. x1 equals 2 over 5. x2 equals 22 over 10. And so, last thing before we end this video is, how would we check this? Because I made a mistake when I was doing this earlier, and I had to recheck. And the way you do that, check, you plug back into our original equation. Either one, we should get the same answer. If you're really meticulous, you'll do both. So let's do the first one. 4x1 plus 2x2 equals 6. Right? So we can do 4 times 2 over 5 plus 2 times 22 over 10. And I'll let you check the math. That will equal 6. All right. Thanks, guys, for listening. As always, please leave a comment or something. Thanks.